So this question, we're given the solution to a differential equation, and it's a general solution. We have these two unknown constants, C1 and C2, and we have two initial values. We know that y of 0 equals 1 and y prime of 0 equals 0. And we're looking for the particular solution that satisfies the initial conditions. So what we need to do is to find y prime, plug in these initial values, and then we'll be able to solve for the two constants. So let's just start with finding the derivative. So what's y prime? We have to use the chain rule here. So this will be 2c1 e to the 2t. This will be negative 3c2 e to the negative 3t. All right, and now we're going to apply the two initial values. So when we say y of 0 equals 1, we mean that y is equal to 1 when t is equal to 0. So we're going to plug those in. So I'll do this in a different color. So y is equal to 1 when t is equal to 0. Oh. And e to the 0 is just equal to 1. So these kind of cancel out just because 1 times anything is just itself, right? So this gives us this equation, C1 plus C2 equals 1. And we're going to do the same thing with y prime. Y prime of 0 equals 0. So say this is equal to 0. And I'm going to plug in 0 for t. So just like before, e to the 0 is equal to 1. So I'm not going to bother writing that down. Again, e to the 0 equals 1. So I get this equation. So this says that 2c1 minus 3c2 equals 0. So now I just need to solve this system of equations. There's a bunch of different ways to do this. You can use matrices. You could use substitution method. I'm going to use elimination. Let's multiply this equation by 3, and that'll give us 3c1 plus 3c2 equals 3. I'm just going to add these two together. Here I get 0. This gives me 5c1 equals 3. So I get c1 equals 3/5. And then I need to plug that back in. Let's plug it in here to solve for c2. So 3/5 plus c2 equals 1. So c2 is 1 minus 3/5. So that's got to be 2/5. That's c2. So we would say our particular solution would be 3/5 e to the 2t plus 2/5 e to the negative 3t. So that's our particular solution.